Okay, in this we'll be solving paper 6, Investigation and Modeling of October-November 2021. The part is investigation, which is from question 1 to 3. This is about Girard sums. Albert Girard, a 17th century French mathematician, investigated numbers n that can be written as a sum of two squares, a square plus b square. This task is about these numbers. So for this task, a and b are integers where a is greater than equal to 0 and b is greater than equal to 0. So we just have to complete this table. So this is pretty simple. So the first row is already completed. Second one, so you have the number is a, so a square, that is 18 square. So 18 square. So if you know the square, you can directly write it as well. So 18 square is 324. 324. 10 square is 100. And then I add the 2. That gives me 424. And 424 divided by 424 divided by 4 gives you 106. Similarly, 28 square. We have 28 square. That gives you 784. 784 plus 256. That gives you 1040. 1040 divided by 4. That gives me 260. So the remainder is 0 here also. Similarly, moving further, we have 4 square is 16 and square of 8 is 64. So this will be 8 over here. 16 plus 64, that gives me 80. 80 divided by 4 is 20. 144 is the square of 12. 12 square is 144. 196 is the square of 14. And 144 plus 196. 144 plus 196. That gives me 340. 340 divided by 4, 85. So remainder is 0 again. 20 square is 400. So I have the total as 884. So 884 minus 400. That gives me 484. So this is 484 and square root of that. So square root of answer, I think this is 22. So this is 22. And here we have 225 is the, okay, 900 is the total. So this is 30 because this is already 0. So 30 square is 900. So this is our table. This was for 5 marks and very simple. If you know the square, I think this should just be a 2-minute work. Now the second part is B, question 1B, first one. When A is 2, B is 4, then N is 4K. So N is a multiple of 4. Find the value of K. Okay, so this is referring to, we can say that this is A is 2, B is also, B is 4, and then N is 4K. Okay, so then what is the value of N? N is equal to A square plus B square. That is 2 square plus 4 square. That gives me 20, which is 4 into 5. So this is my K. So K is equal to 5. Next, the values of A and B in the table are all even numbers. So when A is equal to 2m, B is equal to 2n, then N is equal to 4k. Find an expression for k in terms of m and n. Okay, so again we have to write n. N is a square plus b square. So we'll just substitute the values. So this is n is equal to 2m, that is my a square, plus 2n the whole square, that is my b square. That gives me 4m square plus 4n square, which is 4m square plus n square. Hence I can write that k is equal to m square plus n square. Not all multiples of 4 can be written as a sum of two square numbers. Show that there are no values of a and b that give k is equal to 11. So let us write. So what this means is n is equal to 4k, which means m square plus n square from this result. This m square plus n square is equal to 11. So m square plus n square is equal to 11. So what we need to see is whether 11 can be split up as a sum of squares of two numbers. So we have to show that there are no values of a and b which give k equal to 11. So obviously we are taking m square plus n square is equal to 11, and if we can say that there are no integers m and n, or there are no numbers which give us the total 11, the number should be squares. So then that automatically proves. So let us just check. 11 is equal to, I can write as 0 plus 11, neither of them are squares. 1 plus 10, I can write 2 plus 9, 3 plus 8, 4 plus 7, 5 plus 6, and then it will repeat. So I can see that I am not having both the pairs as perfect squares. So both pairs are, rather not both pairs, but both numbers in the pairs are not squares. Hence, we can show that there are no values of a and b. Now again, simple table here. So this is a square, b square, and n is given as a square by b square. Here we can see that this a and b, they are odd numbers. So 21, square of 21 I know is 21 square is 441. 441. 19 square. 19 square is 361. And you add both of them, you get the remainder as 2. Okay. Similarly, 289 and this is 914. So 914 minus 289, that gives me 625. So this is 625. Square root of 625 is 25. And 914 divided by 4. Let's see. 914 divided by 4. Okay, this is 228.5, or I can just, this is like 457. Okay, so the remainder here also will be 2, because you can see 914, half of 914 is 457. So if I divide by 4, the remainder will be 2 over here. So we can also check, it's like the quotient over here is 228. So 228 into 4 plus 2. So the number over here is 228, 228, and the remainder is 2, and divide by 4. So 228, you can just check this once. So 228 into 4 plus 2, that gives us 914. Similarly here, okay, this b square is 7, so this is 7. So 49, 170, and 70 minus 49. That gives me 121. Square root of that is 11. And again, I'm expecting the remainder to be 4 again. So 170 divided by 4 gives me 42.5. Yes, so again this is 42 and remainder is half. So this is like basically 42 and half. So if I do 42 into 4 plus, this is like, you can just see that this is division by 4, but because 2 is cancelled out, so we can just check 42 into 4 plus 2, 42 into 4, that gives us 170. Right? Here again we have both of them are 1 1, so 1 1, and total will be 1 square plus 1 square, which is 2. Remainder is definitely 2. So here 2 divided by 4 gives me the quotient is 0, remainder is 2. So this table is also completed. Next part, when a is an odd number, a is equal to 2n minus 1. Use algebra to explain why a is an odd number. A square divided by 4 has remainder 1. When a is an odd number, this is having a remainder of 1. So we can see that a square over here is 2n minus 1 the whole square. That gives me 4n square minus 4n plus 1, which is 4 into n square minus n plus 1. So this is like when a square is divided by 4. So I can say this is like of the form, this is my divisor into quotient plus remainder. So I can write that when a square is divided by 4, the quotient is n square minus n and the remainder is 1. Hence we have proved. Why? For the values in the table in part A, n is always 4k plus 2. Okay, so for the values in the table, we can see that A and B are, they are odd numbers. So if A and B are odd numbers, so maybe I can write them as, let's say A is 2n minus 1, B is 2m minus 1. So if I treat them as odd numbers, A square will become 4n square minus 4n plus 1, B square becomes 4m square minus 4m plus 1. So I just add them. Okay, in fact, I can also write it in the form which was over here, that is this 4n square minus n. So I can also write it that way, that is 4n square minus n plus 1, and this is 4m square minus m plus 1. I can also write this is an odd number, so odd number can also be plus 1 or minus 1, doesn't matter. So that will make it plus 1. So I'm just using this result. So I think I'd rather leave it as minus 1 only. So this is of this form. And now, so if I say n is equal to a square plus b square, that gives me 4 is common here. N square minus n plus m square minus m. This is common, plus 2. So which can be written as the form of 4k plus 2, where this is my k. Hence we have proved that When A and B are both odd, n is equal to 4k plus 2. So n is a multiple of 4 plus 2. Not all multiples of 4 plus 2 can be written as a sum of two square numbers. Find all the values of k from 1 to 9 where n is equal to a square plus b square. Okay. So we need to find out some values. Find all the values of k from 1 to 9 where n is equal to a square plus b square. So if n is equal to 4k plus 2, so n is a multiple of 4 plus 2. So not all multiples of 4 plus 2 can be written in this form. So let us just take some values. We'll take all possible values of k and the corresponding value of n, which gives us. So let's write it down. We can just use a table function of the calculator. So let's say k is equal to 1. I'll just write it first. K is equal to 2. K is equal to 3. K is equal to 4. K is equal to 5. K is equal to 6. K is equal to 7. K is equal to 8. K is equal to 9. I'll find out my corresponding value of n. N is equal to 4k plus 2. 4k plus 2. So I have to try values of k from 1 to 9 and the corresponding value of n that I get over here. You can quickly use your GDC for this also, though you can do it manually. I'll just quickly use the GDC here. So this is my table. I will just input over here, which is 4x plus 2. Let's delete this one. Okay, so I'll just set it from 1 and 9, 1 to 9. Okay, that's it. So that's my table. You can see that I get the values of n as the corresponding value 6, and I get 10, n is equal to 14, n is equal to 18, and as I go further, 22, 26, 30. So 22, 26, 30, and 34, and 38. These are my values of n. Now, some of them will give me two numbers which add up to this particular value of n. Here if I see this is 6, so 1 plus 5, no, it won't give 1 plus 5. Just have to try 1 plus 5. See, what are my perfect squares here? So I have my perfect squares 1, 4, 9, 16, 25. So let me just see. Okay, so it's like 1 plus 4. No, it will not give you. Here also 10. I'm not. Can I get 10? Yes. 10 is 1 plus 9. So this is 1 square plus 3 square. So this is definitely one of the numbers. 14. None of the numbers add up to 14 over here. So this 14 is not working. 18. Yes. 9 plus 9. That is 3 square plus 3 square. So this is also one value. 22, I'm not going to get 22 also. You can just try different combinations. Say like if I just start with 1. So 1 plus 21, then 4 plus 18, 9 plus and so on. You can just check that you will not get it. 9 plus, this will be 9 plus 13. 16 plus 6. No, so this won't work. 26, I think this works. This is 1 plus 25 or 1 plus 5 square. And so this is also one value. And then 30 again, 1 plus 29, 29 not a perfect square, 4 plus 26 and so on. 4 plus 26, we have 9 plus, no, so this is also not going to give me. So you can just use your GDC if you wish, but this is more of mental calculation. And then 34, I think you can just get 34. Let's say I will just try 1 plus, no, 4 plus 30, no, 9 plus, yes, this is 9 plus 25. So 9 plus 25, which is 3 square plus 5 square. So this is another one. So find all the values of k from 1 to 9. So the values of k are k is equal to 2, 3, no, 2, 2, 4, 6, 8. In fact, all the even numbers. Now, the values of n that can be written as a sum of two square numbers are of the form 4k plus r, where the remainder r is a constant. Explain why r can be 0, 1 or 2, but it cannot be 3. Okay. So let's see, we have some previous cases here. We have already seen that in the first case, that is when both the numbers are even. This is when both the numbers are even. So when both numbers are even, so suppose when both numbers are even, n is equal to 4k, which means 4k plus 0, which implies r is equal to 0. Now when both are odd, when both numbers are odd, n is equal to, we have seen this earlier, when both are odd. This is the result when both are odd. That is n is equal to 4k plus 2. We've kind of had a generalization over here. This was when both are even. When both are odd, there's always 4k plus 2. So we can write that this is 4k plus 2, which implies r is equal to 2. Now when, suppose if I have one odd plus one even, so this is like, suppose it is one odd means 2 n plus 1 square, and one even, let's say that is 2m. M could be any number. So this will become 4n square plus 4n plus 1 plus 4m square. You can see this 4 is common here. N square plus m square plus uh, n plus 1. So this is like my of the form. So I can add this is 4k plus 1. So it cannot be 3. Hence, this means r is equal to 1. Hence, we say that r cannot be equal to 3. N is a square plus b square. Find all the values of n where n is between 10 and 30. Okay. So again over here, you can just make a table here. I just want the values of n such that it is the sum of square of two numbers. So n is of the form. Okay, so let's say I will take different values of k, which will give me values of n between these values. So supposing if I take k is equal to 1, that gives me 4 into 1 plus 1, which is 5, not yet. Similarly, if it is 2, this is 4 into 2 plus 1, which is 9. I'll start with 3. Okay, so I can just start with the values of k equal to 3. So if k equal to 3, I'll get the corresponding values of n. And then I just need to check whether it is going to give me sum of squares. So again, you can just try out the table again over here. So let's say my formula is 4k plus 1 in this case. So I will just change this to 1. And I'm going to start from, let's say 3, k is equal to 3. And let me end at, let me just try, it should be up to 30. So 4 sevens are 28. I think that should be okay. So I'll just end at 7 with the steps with steps of 1. Let's start the table. Okay, so you can see that find different values of n. So here my n is 13. So I'll just draw a table in fact. So n is 13, n and a square and b square. So let's see. We'll just see for n equal to 13. In fact, we can just check if it is giving us. So n is 13. If n is 13, do I get, again I can write my squares, 4, 1, 4, 9, 16. So if, am I getting 13? Yes, 4 and 9. So I'm getting this as 2 square plus a square and b square will be 4 and 9. When n is 13, okay. So when n is 17, I think even for 17, 1 and 16, you can see just by observation. So when n is 17, this is 1 and 16. When n is 21, for 21, I think we may not get because 1 plus 20, 4 plus 16, and 9 plus, no. So 21 you're not going to get because 9 plus 12, and then after that 16 plus 5, that will not work. So let's try 25. Yes, 25 we can take because 25 is, again, one of the numbers can be simply 0. So 25 is 0 and 25. And the next number is 29. Will 29 be possible? 1, 28, 4, 25, yes. So 29, 4 and 25. So, and that's the last number. So find all values of n where we get it as a square plus b square. They are perfect squares and it's of the form 4k plus 1. So my numbers are 13, 17, 25 and 29. So this was the investigation part. Now heading over to the modeling part. So this is again 30 marks and you're not advised to spend more than 15 minutes on this part as well. Okay, so let's read this. This task is about the number of computer tablets and mobile phones a company makes and sells. Okay, so this is about production boundaries. This will be very similar to in fact, it is the production possibility curve which we have learned in economics. The company owns two factories, A and B. Factory A makes A tablets and A phones. Factory B makes B tablets and B phones. The production boundary is a curve or line. Points on the curve or line are the maximum numbers of the two items a factory can make when all resources are used. It is the boundary of the region which shows all combinations of the two items in a factory can make. So the first part, so just to understand this, they have given a formula. So here you have number of A phones, number of A tablets, and you have a curve which connects the two quantities. Factory A makes T A tablets. T is the horizontal scale, and P A phones each day. The manager of factory A uses the model P is equal to 9,000 minus T square by 100, where T is greater than or equal to 0 as the production boundary for the output of A tablets and A phones. On the axis below, sketch this model. So let's take our GTC. This is 9,000. This is 9,000 minus x squared by 1,000. I also need to set my x minimum and y minimum to 0. Let us first do this right away. X minimum is 0 and maximum is 4,000. So 0, sorry. 0, this is 4,000 maximum. Scale doesn't matter, I'll just keep it as 100. and y minimum is again 0, and y maximum is 10,000. Okay, so let's draw this. Okay, so this is my curve. I should know what this point is. So how do I know this point? I will just find out the y-intercept first. So shift G solve and y-intercept. Y-intercept is 9,000. So let's say this is 9,000. I also need my x-intercept. So let me just find out the root of it. That gives me 3,000. So this is 3,000. Just join them. This is my curve. So slightly. Okay. So this is my production possibility curve. When factory A makes 9,000 A phones, it cannot make any A tablets. Write down the maximum number of A tablets it can make when it does not make any A phones. So it does not make any A phones, meaning this axis is 0. So when this axis is 0 means it is this. So when A is 0, it will make all A tablets. So the answer is 3,000. So when this is like the point. This point corresponds to 3,000 comma 0. So 3,000 tablets, and this 0 means there are no A phones or 0 A phones. So every point on this curve will give a combination which is the optimum production which the factory can make. On Monday, factory A makes 8,000 makes 1,000 A tablets. On Tuesday, factory A makes 1,500 A tablets. Find the decrease in the number of A phones it can make from Monday to Tuesday. In order to find out phones, my formula is this. So the phones that it can make over here. So on Monday, P value will be 9,000 minus this is T square, that is 1,000 square by 1,000, which is 8,000. Similarly, for this, we have 9,000 minus 1,500 square upon 1,000. That gives me, let's check. So this is 9,000 minus square upon 1,000. That gives me 6,750. So I have to find out the decrease. So from 8,000, it decreases to 6,750. So 8,000 minus my answer, that gives me 1,250. So this is my decrease. Okay. So the D part, on Wednesday, factory A makes 5,000 A phones. Use your graph from part A to explain why it is not possible for it to make 2,500 A tablets on Wednesday. Okay, so if it is making 5,000 A phones, so let's say 5,000 A phones means this is somewhere over here 5,000. We can just use our graph also again, going back to the graph. So 5,000 is the number of phones. Use your graph. Okay, so if it is 5,000 A phones, corresponding tablets I need to find out. So if this is 5,000, somewhere over here, what is the corresponding phones it makes? So let us just check. Shift, let me just say, I just need to calculate the corresponding X value. So Y value is 5,000. That gives me corresponding X value as 2,000. So this is 2,000. So hence I can write this over here. that when it makes 5,000 A phones, it can only produce 2,000 A tablets. Hence, it's not possible. On the graph in part A, shade the region that represents the number of A phones and A tablets that the factory can make. Okay. So we have this entire region, like I can make this is the optimum uh, like the place. Anything below this is possible. So that is what they are asking, that the factory A can make. So it can make anything which has, like suppose if I take this point, this might correspond to somewhere close to 1,000 and maybe 6,000. So it can make these many. Though whatever is there on this boundary is the optimum. So I can shade this entire region which represents the number of tablets and phones that it can make. Now the E part, the company sells all the A phones and A tablets that the factory A makes each day. The company makes $160 profit for each A tablet and $100 profit for each A phone that it sells. The greatest possible daily profit at factory A is $964,000. Write down a linear equation for this profit in terms of P and T. Okay, so the profit is the profit for A plus profit for B. Oh, sorry, profit for tablet and profit for phone. The profit for the tablet is 160 and it is selling T tablets plus 100 phones, not 100 phones, $100 and P phones. The total profit is 964,000. And we just have to express in the form P equal to MP plus C. So let's write this as 100P is equal to 964,000 minus 160T. I can rewrite this as P is equal to divide throughout by 100. This becomes 1.6 minus 1.6 T plus 9640. This is my final expression. Find the number of A tablets and A phones that the factory A should sell in order to make a profit of 964,000. Okay, so this is what I need to do. So I just need this condition as well as this condition to be satisfied, which is my given production possibility. So I just have to solve them simultaneously. So it's like, just for explanation, minus 1.6T plus 9640 is this is equal to 9,000 minus T square by 100. So I just have to solve this simultaneously. Okay, so they have to be equal. So we can just have another curve and just see where they intersect. So we've already done this. So let us draw minus 1.6 x. Oops, okay, wait. I don't want it to do that. Okay, let's take a new. This shouldn't be disturbed. So minus 1.6 x plus 9640. That gives you, let's draw this. Okay, I need the point of intersection. So shift, resolve, intersect. So that gives me x is equal to 800. So x corresponds to t, that is 800, and p corresponds to the y, that is 8360. You can also draw this just to explain that what you have done here. You can just simply just draw a line here like this. So just to show, so this is your point, this particular point. This is the line which is minus 1.60 plus 9640. Minus 1.60 plus 9640. And this is my point, which is 800, comma 8360. So in this sketch itself, this can also be like a method which you're showing. Okay, so now the next part. Factory B makes T B tablets and P B phones. The table shows the maximum number of B phones that the factory B can make each day for some number of B tablets. There's a table given. Now we don't have a function, but we have a table. As the number of B tablets increases, the number of B phones decreases at a constant rate. Okay, so this is very important, at a constant rate. So when I say at a constant rate, you can see that for every decrease in 2000, I have a increase in 1000 actually. This is plus 1000. So if I just take another 1000 here, which becomes 5000, this will become 0. And similarly here, if I go up, this will become 10,000, and this will decrease by 1000, which will become 0. So I think that's a hint for me that I can just have this. This is 10,000, and this is 5,000. Now I can just draw a straight line here which connects the two. So this is my production boundary for this. It's a linear curve, not a curve actually. So find the equation which models this production boundary giving P as a function of T. So I can easily make out now what is my value of M. M is rise over run. I can say it's a negative slope for sure, which is I can write it as 0 minus 10,000 upon 5,000 minus 0, which gives you minus 2. So this P is equal to minus 2T plus the y-intercept is 10,000. Y equal to mx plus c. That is of that form. Next, factory B makes at least 1000 B tablets, but no more than 4000 B tablets each day. Write down the domain of the model in part A. 2. The domain means what are the values which T can take. T is the number of tablets, so it is saying that it is between 1000 and 4000. So I can add this is 1000 and 4000. So this is my domain, that is the possible values which T can take. Next, the company sells all the B tablets and B phones factory B makes each day. The company makes $200 profit for each B tablet and $190 profit for each B phone it sells. Each day the manager of the factory B expects to make the greatest possible profit. So let us see what is the profit first of all. So profit will be 200 for tablet. So 200 T if he sells 3 tablets plus 190 for each phone. 190 for each phone. Okay. Now if I write in terms of the same variable, now there are constraints on T and P also. So I can just put this value of P over here, which gives me, so I'll just get in terms of T. So that is 2000 T plus 190 into my P was minus 2T plus 10,000 plus 10,000. That gives me minus 180 T plus, and we have, so that is 1,900,000. So I want the greatest possible profit. So this t should be as small as possible because this is 1 minus negative 180. So from the domain, I'll pick up the smallest possible value of t. So the maximum profit is when this t is minimum, that is equal to minus 180 into 1000 plus, okay, this is 190000. So we can just check this out. So this is minus 180 into 1000 plus 19 1 2 3 4 zeros. That gives us, wait, hold on, this is, I think I just put 1 0 less over here. 1 2 3 4 5 1 2 3 4, yeah, one more zero. So we have this as, yep, is one more zero here. So that gives you 172 1 2 3 4. Just be careful of zeros here. So one day factory B has to make 2500 B tablets. On this day the profit is 73.3% of the greatest possible profit. Work out the number of B phones factory B makes on this day. So my profit here is 73.3% of the greatest possible profit. So this is my greatest possible profit. So into 73%, so 0.733. So my profit is 1260,760, and T is 2500. That is the number of tablets. I have to work out the number of phones. So I can use the same condition which was there for the profit. So profit was, I can partially use this as well. That is 200, but I need to find out the corresponding value of P. So this step is what I can, this form I can use it. Because I want the maximum profit. So in fact, maybe I can use this. Yeah. Because I want the profit, right? Yeah. So let's try this out. So I have to find out. So I can put this in the equation. 1260,760 is equal to, I need to find out the value of the B phones that are made. Okay. So how many phones? So I will just write this as, this is what I need to use. 200 into 2500 plus 190 into P. So let's find out P. So this is 126. So it's like 1260760 minus 200 into 2500 upon 190. That will be my P. So let me just do that. 1260760 minus 200 into 2500 divided by 190. It gives you, so P is 4004. So P is 4004. The number of phones that can be made are 4004. Next, the company puts new machinery to make phones in factory A and factory B. Factory A can now make double the number of A phones. Factory B can make 10% more B phones. All other conditions remain the same. Complete the following models for the production boundaries at each factory after the changes. Use the model in question 4 and 5A. So what is in question 4? I think that is for factory A. So question 4 is for factory A. So this is the model that is given. They just mentioned that it is double the number of A phones. So I can just say now this is the number of phones is double than what it was previous. The double of what is it, 9,000 minus t square by 1000. This is t square by 1000. Yes. So this is t square by 1000. Next, all other conditions remain the same. It can now make 10% more B phones. We can see that this is 10% more than what was there earlier. So our earlier condition was this. If I take 10% more, means into 1.1. Into 1.1 gives me this. Because all other conditions remain the same, this will not change. So this will remain as the same. The domain of that will remain the same. So this remains the same. That is 1000 to 4000. So this is 1000 to 4000. After the change, the greatest possible profit made each day by factory A is this. That is 1,830,000. Find the total greatest possible profit made each day by the company. Okay, so factory A is this. So we just have to add this. So let's see for factory B. Okay, so profit for B. Now the profit for B we had seen earlier. What was the formula? That was 200T plus 190P. Okay, so this P has changed here. Instead of this, now we have a new formula. So this is 200. We'll just write it for now. So 200T plus 190 into, it is this value, that is minus 2.2T plus 1,100. No, 11,000. So what is T over here? We have to find out. Okay. Yeah, the greatest possible profit I need to find out. Here they have already given. So again, if I just calculate this, what do I get here? This will be some negative value, which will be for T. Coefficient of T will be negative. So I have to take the smallest possible value of T to give me the greatest value of the profit. So this gives me, so again it has to be 1000, because the smaller the number, the greater the profit will be. This is 2000 into 200 into 1000 plus 190 into minus 2.2 into 1000 plus 11,000. So that gives us, let's see, 200 into 1000 plus 190 into negative 2.2 into 1000 plus 11,000. That gives you 11872. Now this plus 180. So 187200 plus 183. Just have to add this plus 183, four zeros. That's my overall profit. That is 3702. This is my total greatest profit. That's it with this paper.